All right, confidence intervals part 2. The confidence interval I'll probably draw and use the most, although it's just because it's easy, is the 95% confidence interval. And the other day we learned that that's not exactly 2 and negative 2. It's more like 1.96 and negative 1.96 for z. Oops, that's not a 6, that's 2. This is an important thing. Confidence intervals, let's see, confidence intervals. I'm not writing very well on this Thursday. It's because it's already almost Friday in my mind. Confidence intervals are not probabilities. Here we talk all about probabilities, and now we're talking about something that's not a probability. They're not probabilities about parameters. I will guarantee that you will see questions, and I would be willing to bet that if you take the AP test, you will see a question that asks a multiple choice about confidence intervals, and the answer says something about probability, the probability that that the parameter occurs here or there. Confidence intervals are not probabilities. If you see the word probability and confidence interval, you run for the hills. You do not choose that answer. Nor do you say the probability is the probability that we've captured the true parameter, whatever that is. I'll use mean as an example. Could be sigma, is either 0 or 1. We'll never know. So when we take a sample and we set forth a confidence interval based on the statistic of the sample, x bar, p hat, something like that, and we say, hey, we're this confident, 90%, 95%, 99%, whatever, that we've captured the true mean in our interval, or the true proportion, or whatever it is that we're looking at. We really don't know if we have or not, and we'll never know. So either we have, and it's in our interval, that would be 1, or we haven't, and it's not in our interval, it's in one of the tails, and that would be a 0. So the probability is either you did or you didn't. There's no in between on that. So that's why I say it's not a probability, unless they refer to it this way, either 0 or 1. That would be the only way a probability answer involving confidence intervals could be answered as correct. Okay. Yeah, so either we have captured it, it being the parameter, that's your 1, or we haven't. far so good? The thing that's hard about confidence intervals is we're talking about a percent of some number, and it looks like probability, it smells like probability, it feels like probability, and yet it's not. And that's the deeper understanding of why this doesn't work. So if this takes a little while to sink in, that's fine, but stay away from anything. You don't say anything with probability with confidence intervals or whatever. All right, so a couple other details about the curve. So I'll go back to my 95% confidence interval that I love so well. Keeps me out of trouble. 95% confidence interval. We have critical values. Critical values lie outside of the confidence interval. Bless you. Critical values lie outside the confidence interval. They're the tails. And in a 95% confidence interval where we have 1.96 here and a negative 1.96, in this example, our critical values are going to be greater than 1.96 or less than negative 1.96 in this example, in a 95% confidence interval. Those numbers change depending on how wide your confidence interval is. Okay. Are we good so far? Okay. All right. Then, how can we affect margin of error? Proper English in there. How can we affect the margin of error? Margin of error is it's a width. You know, it's the day before Friday. You can't take one without all of them.
No, I'm not taking anybody, it's just a message.
Oh, it's just a message? Well, everybody should get a message. What's the message for everybody?
It's from their mom. I mean, you can read it to everybody.
Oh, well, I don't want to do that. But
Oh, well, let's see.
I just wondered if, you know, maybe he had a message for all of you, a message of love and hope, perhaps.
Oh,
I don't know.
We can have lunch.
We can have lunch. Quinn's mom says we can all have lunch.
Yeah,
right?
in general, like you can eat lunch.
Oh, she didn't say like we can all.
No,
She's
in general, you can eat lunch.
okay. You can eat lunch.
You are physically allowed.
Do you regularly have to have permission to eat lunch?
It depends. Every day you ask.
All right. I have to wonder if people ever watch my videos like for stuff like that, just go like, what in the world is going on in that class, right? Okay, so how can we affect the margin of error? We're having fun. That's what we're doing. We're trying to have fun in math. That's not always an easy task. Okay. How can we affect the margin of error? So our margin of error is this plus or minus some amount. What are some of the ways, or is there a way that we've learned up to this point that we can affect the width of the curve? How can we affect the width of the curve? Increase our sample, right? Increase the sample size. Absolutely. We can affect it by changing the sample size, I guess probably, but normally we would want to increase the sample size to make it narrower. So we can change the sample size. Good. There's one other way. How else can we affect the margin of error? Yeah.
Increase or decrease maybe what you need.
Well, that would be done by increasing the sample size. Yeah. We could simply change the confidence interval. Instead of a 90%, we make it a 95%. Or instead of a 95, we make it a 98 or 99 or whatever we want. Right? We can change. We have the power to set the confidence interval wherever we want. So we can change. How about we say by the confidence interval chosen? And we talked about confidence intervals the other day, about choosing them. What did I do with that? Set of notes. I thought I had them right here. I guess I've hidden them from myself. We've talked about how to choose the different confidence levels, right? If it's a question that's not all that important, what's your favorite Skittle? Nobody's going to sue you if you get it wrong, but the right answer is orange, of course. Then your 90% is fine, maybe even less, okay? If you might get sued, you want 95% or perhaps more. If it's something involving life or death, you're 99% or more, okay? So, interpreting a confidence interval. This is what we kind of just went over in, I think it was problem number 5. We write. This is a skill you have to have. We write. We are blank %, that's your confidence interval, you pick it, or it picks you, or something like that. We are blank % confident the true blank, this is a parameter, mu p sigma maybe even, is between blank and blank, and then add context here. You can actually put the context in lots of different places here. In fact, maybe adding context at the end might be a little less smooth. So how I might write something is I might say, I am 95% confident the true mean of the Coke bottles filled is between 20.05 ounces and 19.95 ounces, maybe, or something like that. I'd probably put the lower number first, but I wasn't thinking quickly enough as I was giving my answer. So, yeah, add context here, or perhaps here, something along those lines. You need to get the context in though. Otherwise it won't go well for you. So this is something that you have to get. We're going to get lots of practice in it. Don't slough it off there. Okay. So in essence, what we have is say I have a sample of sodas. I'm checking the bottles. Here's my 20 ounces. That's exactly what I wanted and exactly what the bottle says. Got my 95% confidence interval so that nobody sues me over filling my bottles incorrectly. So this is negative 1.96 standard deviations. This is 0 standard deviations and 1.96. So we are 95% confident. I do some abbreviating usually for that stuff, but not today. The true mean number of ounces filled is between 19.95 and 20.05 ounces. That's it for notes. Let's look at a problem. #21 was the problem I did with yesterday's class. It's on page 508 if you want to look that one over with me. It's talking about one of every Californian's favorite things, traffic. I think it's getting to where like people here in Idaho are starting to have to drive a little bit. Well, Idahoans tend to drive very defensively. It's really funny because I think there's a culture in driving that I noticed when I was moving here. Did I talk about this the other day? I mentioned this to another class. So, like here in Idaho, everybody's all like, "Oh yeah, okay, yeah. Oh, you want to get out into from a side road? We'll wait for you. We'll leave you a little extra room because I don't have to pull all the way up to the light, you know. And if I don't make it to the light, it's okay." Idaho's really good about that, where California's maybe not quite so good about that. But Idaho sucks at the zipper. Okay, do you know what the zipper is? When 2 lanes are turning into 1, it's like everybody lines up in the left lane. Everybody lines up in the left lane, and then there's that jerk that takes the right lane, right? And then tries to speed up in front of everybody or tries to get in after everybody takes off, right? The jerk. And all the people in the left lane are like, "That jerk didn't wait his turn. I'm not letting him in." Yeah, I'm talking Idaho here, right? They're really good everywhere else, but they're terrible at that. And what's funny is because if they realized that the zipper would actually get more cars through the intersection, that would be a good thing for traffic here. But no, they line up 3/4 of a mile long in the left lane, and then they won't let anybody in, right? Hey, you want this lane? You should have thought of that 5 miles ago, buddy, and you should have pulled in a long time ago. Am I right? I know I'm right. Okay? I'm right. Okay? That one's bad. Hey, you know what? I tend to take the short lane too, and especially if I had a high-performance car where I knew I was going to beat everybody, then I would always be in the left, in that short lane, every time. But a Honda Civic just doesn't even compare to the SUVs these days. So, okay, so there's my traffic rant for the day. Don't get me wrong, I love Idaho. I'll put up with that. Sometimes I'll even sit in the left lane just because I want to be Idahoan, all right? But a lot of times I'll just kind of go, all right, you jack wagon, I'll let you in when nobody else will, okay? All right. So this problem says, people love living in California for many reasons, but traffic isn't one of them. Based on a random sample of 572 employed California adults, so N equals 572, a 90% confidence interval is constructed for the average travel time to work for all employed California adults. And they say that's 23 minutes to 26 minutes. So 90%. We got 26 minutes here, and we got 23 minutes here. So our critical values are anything more than 26 minutes or anything less than 23. And so what's our I keep forgetting the term for that number at the top.
23 minutes, 30 seconds.
Should be 24.5. Yeah. Okay, so I filled in some stuff. Sometimes just by filling that in, you answer a bunch of questions. So A says, interpret the confidence level. Okay, I didn't give you notes on A, mainly because I knew it was coming up in this. Interpreting the confidence level is a little bit different than interpreting the confidence interval. And they sound an awful lot alike, and they actually kind of look a lot alike. But this is how we would interpret the confidence level here. 90% of random samples of California commuters of size N equals 572. Remember, we always have to have the same sample size, otherwise you change your width. We'll have a mean value between 23 and 26 minutes. So if we kept taking more and more samples of the same size from the same population, 90% of those samples should fall between the 23 to 26 minute range. For the record, I moved from a place in California where this is the traffic, actually. There was, you know, cows crossing the road was traffic. Okay. B. Actually, it's more like bees. Sometimes you'd be driving along in the spring, and it can be bad here too, but like you just get pelted with loads of bees and bugs and stuff. B says, name 2 things that you could do to reduce the margin of error, and what drawbacks do these actions have? How could we reduce the margin of error? We just took notes on it. We could increase the sample size, right? Now, I haven't read what the book says about problems with that. I'm not sure that I can come up with a problem with increasing the sample size. That almost always is a good thing. So I don't really see a downside to that one myself. I'll look at the book here in a minute and see what they say, but I don't see a downside there, or downside. What's the other way that we could change our margin of error? Yeah, we could change the confidence interval. Now that does have some downsides. Confidence interval change. Plus or minus. If you make it less than 90%, your likelihood of capturing the true parameter that you're looking for becomes less, right? If you make it more than 90%, well, I think it's sort of unnecessary in this situation. I don't think it's, I just don't see it as a necessary down. It's not really a down, but I just don't know that it's necessary. So, but making it less, you're going to capture less. You're going to capture more, but then if you make it larger, but it's just sort of not necessary in this context, I don't think. Let's see. All right, then this one's kind of an important one. Describe how non-response might lead to bias in the survey. Does the stated margin of error account for this possible bias? Okay, in my opinion, C is where this question really gets good and gets really AP-ish, because you really have to start thinking about, kind of think outside the box, if you will, outside of the curve maybe. And if somebody's not responding to a survey about how long their traffic commute time is, what might be causing them to not respond to a survey? There. Is that where you were going? Or, yeah. No, you're good. It's all right. It's all right. Yeah. They get home after commuting for 2-3 hours, some people, in each direction. They get home, they look at their mail, and they go, I don't have time for this. I'm going to go to bed. Right? Hey, give me a hamburger and send me to bed. Yeah, they just might be commuting way longer and not have the time. They're buried in traffic. They just don't have the time.